Okay, hello everyone. So for this chapter 4, right, I'm not going to go into the technical or what I call the theoretical aspect of your cathode ray because your cathode ray is basically a lot of factual information, all right? But if somehow you really don't or you really cannot understand how or what is actually a cathode ray, you can just leave a comment below and then I will just produce the video for the earlier part, okay, if you guys really need it. All right, so I'm only focusing on the things that are really important here. Okay, so the first thing that I'm going to share with you guys is the cathode ray oscilloscope. Okay, how do we identify the shapes and how to sketch different waveforms of the CRO. Alright, so by now, if you're watching this video right now, I'm sure that you've already completed your syllabus. Alright, so this video is meant to be like a revision for you guys. Okay, so we need to know the different types of wave that is produced from a CRO. Alright, so the idea is very simple. Let me teach you the concept first. Alright, if it's a DC current, right, the type of shape that you will see on the CRO or the cathode ray oscilloscope is a dot. Okay, and if it's an alternating current, you're going to see a straight line like this. Now, there's a reason why it's a straight line. Okay, now, you will see a dot when the time base is off. Okay, so for a CRO, a few things that I will show you is, number one is the X shift and Y shift. Alright, next will be your time base and also your Y gain. Alright, these are the four of the most important things in a CRO. Okay, so I'm just going to show you the effect of a time base. What do we mean when the time base is off and when it's on? Alright, okay, so I'm just going to show you a simulation here. Okay, now the simulation that they are using here, they are using the alternating current. Alright, now alternating current meaning you're going to and fro, right? So if it's to and fro, what you will see is that instead of having a single dot in the middle, the thing will go up and down. Okay, so let me just show you. Alright, now if you focus on the left side here, right, my mouse here, you will see that the green dot is moving up and down. Okay, because alternating current. So to and fro. Alright, but this is when my time base is off, meaning I haven't on the time. Okay, your time base is your x-axis here. Okay, so when my time is 0 seconds, meaning haven't on, my alternating current is only going up and down. Okay, now watch what happens when I increase my time base. Oops, okay, a little bit lag. Why so lag? Okay, let me just do this. Alright, okay, so now watch what happens when I increase my time base. Okay, so when it starts, when you have your time base, right, then you will see the, let me just start over again. Alright, so when time is 0, this dot here, right, is going to move up and down only, alternating current. And then once you start your time, okay, meaning once you start your x-axis, then only the dot will go like this. That is why the shape of the alternating current is like that. Okay, people identify the shape of the alternating current is based on the CRO. Alright, okay, so watch what happens when I decrease the time base. Okay, you can see there's a change in the wavelength. Okay, basically the time base is to allow us to see, for example, one wave is how many seconds. Alright, don't worry, I'll teach you later on how to see this. Just to show you the effect of time base, which is this one, and the effect of your Y gain. Y gain meaning the voltage. So if you see if I were to increase or decrease, right, you will see that the shape will increase. Okay, so this is Y gain. Now from a CRO, the Y-axis or the Y gain allows us to identify the voltage of the circuit. Alright, so by changing this and that, we can roughly calculate. Alright, so later on you need to know how to calculate how to identify or calculate the voltage based on the graph here. Okay, now X shift and Y shift is just basically we are just moving the graph left and right. If X shift, we are just moving it left and right. Alright, it's a little bit lag because I'm recording. Alright, left and right. This is X shift. Y shift meaning I'm moving the thing up and down. Oh, it's not moving. Yeah, this is Y shift. Okay, this one, up and down. Oh, yeah, this is Y shift. Okay, so these are the two or the four important knobs that we normally use in the CRO. Alright, so okay, before that Right, so for a CRO, you need to know the shape. Okay, so when the time base is off for a DC current, you will only see a dot. Alright, now once you're on the time base, right, like just now you see the wave started to move, right? So once you on your time base, there's direct current, meaning straight, then you will see a straight line like this, direct current. Okay, right? And then for an alternating current, when the time base is off, meaning haven't start, the thing will go up and down only. So once you start your time base, right, then it will go start to look like this loop, like just now you see the simulation just now. Alright, so that is how you so that is how we know the shape of an alternating current is like this, and the shape of a DC current is straight. It's based on the CRO. Alright, okay. So users, there are a lot. Okay, normally the CRO is used for us to identify the voltage. Alright, so we are going to teach you how to calculate the voltage based on the CRO graph. Okay, measure short time intervals, wave frequency. Alright, let's just go straight into the main point. Alright, how to determine the voltage based on the CRO. Okay, for this particular part of this exercise, right, this example here, I have already linked the link from the website that I've taken. Alright, it's a very good website, and it's a group of physics teachers from MRSM, if I'm not mistaken. Alright, they have what they call, they made a blog about a website about the physics. So if you go to the website, right, you will see a lot of very good modules. Okay, that is actually very good for your revision. So do check out the website, go to their website, support them. I believe you should actually give what we call appreciation for their contributions. Go and support them, for taking their time to prepare all these things. All right, so go to the website, and then you go and check out the modules that they have uploaded. All right, so they have different modules for different chapters. Okay, so yeah, go and support them. Like. Okay, all right, so let's look at this one. Okay, so first thing, they show you the oscilloscope, and then the question will give you this: Y gain, how many cm, 1.5 watt per centimeter, and then time base. All right, now Y gain is allow us to identify or to calculate voltage. Okay, this one is for us to calculate the voltage. Okay, this one time base, of course, very obvious lah. This one is for us to calculate the period. Okay, so how do we identify or how do we calculate is based on these two things, Y gain and the time base. All right, now first things first, if you look at the graph, we have many squares. All right, each square is 1 centimeter, or sometimes we call it as 1 division. Okay, so the Y gain that they said here is that each square or each centimeter is 1.5 volts. Alright, so first thing, very easy. Actually, this part is very simple. Right, if I want to calculate the peak voltage, now you need to know where is peak voltage. Peak voltage meaning from here to here. Let me use a big, super big one. Peak voltage is here. From here to here. This is what we call peak voltage. Okay, so to identify the peak voltage, you just calculate from here to here how many squares. From here to the top one. So this is 2 squares, right? Each square is 1 centimeter, and each centimeter is 1.5 volt. So I have 2 squares. So 2 times 1.5, you get 3 volts. Very simple, right? Okay, so basically for an alternating current of this shape, okay, the voltage for this alternating current is 3 volts. Okay, just remember, you take the square here, you multiply to its Y gain. They will tell you each square is how many volts. Okay, so now they tell me that each square or each centimeter is 1.5 volts. Done. Alright, what is peak to peak? Peak to peak, very literally, if you translate meaning from top to bottom, from here right until the bottom here. This is peak to peak. Okay, so peak to peak, so VPP. Alright, so to calculate peak to peak voltage, also the same thing, we just calculate the number of squares. Right, how many cms I have here? So 1, 2, 3, 4 cm, right? Each cm is 1.5. So 4 cm times 1.5 volts per centimeter. So what you get is 6 volts. Alright, so technically the relationship between these two things is, if this is 3, this one is definitely 6. It's always multiply 2. If here the peak voltage is 2 volt, right, your peak to peak should be 4 volts. It's always the same ratio one. Okay, and then root mean square. Root mean square is basically like the what do you call, the average voltage, something like that. All right, I'll just make it simple for you to understand. All right, so the formula for your root mean square is this. Okay, your peak voltage divided by cert 2. So for root mean square, all right, your root mean square, okay, you need to take your peak voltage, meaning this one, 3 volts divided by cert 2. Then this is your root mean square. All right, technically it's like your average voltage or something like that lah. This is 2.12 volts. Okay, so the first part here, how to calculate the voltage from the CRO is very simple. All right, they will give you the Y gain. Okay, and then you just calculate accordingly how many squares. All right, and then you just multiply. All right, now next they want me to calculate the time. Okay, so time taken for one waveform. Okay, you need to know how to identify one waveform. Okay, let me just remove this. Okay, there are many different shapes of one waveform. This, from here to here, this is one waveform. Alright, this is one wave. Okay, what if I take a different point? If let's say I start from here, right, this to this is also one wave. If you notice, the number of, or the distance between one wave is always the same. 4 squares. This now is also 4 squares. Let me take another point. If I start from here, this is one wave. So you see, 1, 2, 3, 4, also 4 squares. Doesn't matter where you take. Alright, let's say I take another point. If I start from here, then one wave. You see, this is also one wave. Alright, so you need to be able to identify the different shapes of one wave. Okay, if I take from here at this point, also the same thing. I just go from here, go up, and stop here. You always stop at the opposite same side one. Not same, yeah, opposite same side. Okay, one wave. Another one. If I start from here, go. Okay, you don't stop here. This is only half. Alright, I need to go to the same side, opposite. See? Ding. So this is also one wave. Alright, so as long as you can identify the shape of one wave, then it's easy for you to calculate. Now, so let me take the easiest one. One wave is this one. Okay, alternating current, this is one wave. Okay, so within this one wave, right, if I want to calculate the time, I need to look at the time base. Time base meaning is your x-axis here. Okay, the horizontal line here. Right, so now they tell me that each centimeter is 2 milliseconds. So in one wave here, I have 4 boxes. So 1, 2, 3, 4. Okay, so to calculate the time, okay, you just take this one, 2 milliseconds per centimeter. Okay, multiply to the total length or the total boxes that you have lah. So 1, 2, 3, 4. Each square is 1 centimeter. Alright, so you are going to get 8 milliseconds. Alright, so if I convert into seconds, this one will be 8 times 10 to the power of 3 seconds. So this is your period. Okay, so that is how we identify voltage and period from a CRO. Voltage, look at Y gain. Period, look at time base. Okay, we just calculate accordingly. Alright, now frequency. The relationship between frequency and period is 1 over T. So you take this, just divide this. Alright, so the frequency that you should get is, oh my god, so difficult to calculate. Think. Come on. Oh crap. Okay, so this is 125 Hertz. Alright, so those are the few informations that you can get from your CRO. Okay, alright. This is the part that it will be a little bit troublesome, but it's not difficult. Alright, they will ask you to sketch the trees if we change the settings. Alright, so now we are going to take our peak voltage that we have just calculated. Okay, meaning I need to have the peak voltage and also the period in order for me to draw. So my peak voltage here is, I'm just going to write down here, my peak voltage is 3 volts. And my period here is 8 milliseconds. Alright, So period 8 milliseconds meaning for one wave lah. Okay, so initially is 1.5 volts per centimeter. Now they change the settings to 1 volt per centimeter. So I need to use this peak voltage to calculate how many squares, okay, to get for a 3 volt. Alright, so you just take 3 volts divide by the Y gain. Then you can get the how many centimeter, right? So meaning like this 3 volts divide 1 volt per centimeter. So this one you get 3 centimeter. 3 centimeter meaning now the graph is going up 3 boxes. Okay, so if you see here just now this one is only 2 because the Y gain is 1.5. Okay, 3 divided 1.5 is 2 boxes. So we only draw 2 boxes only. Alright, this one 3 divide 1 because now my gain is per cm is 1 volt. So I need 3 cms in order to achieve my peak voltage 3 volt. Okay, so I know is 3 boxes, 2 milliseconds, 2 milliseconds per centimeter. Any changes here? It's still the same, right? Meaning that one wave is still 4 boxes. Okay, so meaning I take this, divide by this, I get 4 cm. Alright, so meaning one wave is 4 box. Then you go 3 up. So meaning it's like this. Dang. Okay. Oh my god. Really I'll draw this as nice as possible. Oh my god. Okay, let's look at this. Alright, so this is the display. Alright, when the settings are changed to this one. Okay, because now I already calculated that my peak voltage is 3 volts. So now I change the setting is 1 cm 1 volt. So meaning it's 3 cm lah. 1, 2, 3. That is my highest point lah. Alright, and then my time base 2 milliseconds per centimeter. My one wave is 8 milliseconds, meaning one wave is like this, is 8 milliseconds. Just take this, divide this one, then you will know how many boxes for one wave. Okay, right, let me show you a bit more. Let me just show you all lah, then easier for you to calculate. Okay, so again, we are using the same peak voltage. Alright, so 1 volt per centimeter again, so it's 3. Okay, now your time base is 1. Now your time base is 1 milliseconds per centimeter. Alright, so you just take your 8 milliseconds per centimeter, you divide this one. So if you take this, where do I write? Oh, okay. Divide this one. So meaning you get, 8 centimeters, meaning 8 boxes for one wave. Okay, so 1 volt per centimeter is 3 cm. So meaning one wave, meaning from here, here. So one wave, oh my god. So it becomes fatter a bit lah. Wow. Oops. Okay, so let me check. One wave is 8 centimeters. Alright. So 1, 2, 3, 4, 5, 6, 7, 8. Correct. Okay, because and then my peak voltage is 3 volts. Alright, so now it's per centimeter is 1 volt. So 3 lah. 1, 2, 3, 3 boxes. Okay, let's try another one. Okay, now this one is 3 volts per centimeter. Oh, this one easy lah. Okay, so my peak voltage is 3 volts, right? 3 volts per centimeter, meaning 3 divided by this one. So you get 1 centimeter, meaning only 1 box. Maximum amplitude is here. Alright, 2 milliseconds, same thing. 8 divide 2, you get 4. Meaning one wave is 4 boxes, 4 cm. So meaning like this. Okay, maybe I draw not very nice now. Okay, so let me check. One period, 4 cm. So 1, 2, 3, 4. Okay, and then my peak voltage is 3 volt, correct? Because now 1 cm is already 3 volt. Okay, alright, so same thing here. Peak voltage is 3 volt. Alright, remember my peak voltage is based on the original one, meaning you need to calculate first your peak voltage is how much, then only you can draw the changes. Okay, again 1 cm is already 3 volt, so only 1 square, maximum is only here. Alright, T is 8 milliseconds, so now each centimeter 1 millisecond, so I need to have 8 boxes for one wave. 8 boxes for one wave. 1, 2, 3, 4, 5, 6, 7, 8. So I roughly draw like this. Oh, wait, here. Alright. This one will become even more flat. Okay, now in your exam or in your SPM, right, when you draw, right, please draw very accurately. Don't overdraw it. Meaning, something like this happens. I'll just show you an example of. Okay, sometimes the students they simply draw and they try draw, then I draw like this. Now, by right, your peak voltage is only 1 cm. Okay, 3 volts, right? Meaning only 1 square. But if you draw, you overshoot. Meaning this part here overshoot, right? So this one you consider as wrong. Cannot, so you need to draw as accurate as possible. Alright, draw very accurate. Okay, if not, you won't get your marks. Okay, draw until so difficult but never get marks. So sad, right? Okay, let me check. One period is 8 centimeters. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, correct. Alright, this one. Okay, 1.5 volts per centimeter. So my peak voltage just now is 3 volts. If I divide 1.5 volts, okay. Alright, meaning I get 2 centimeters. So meaning it's 2 boxes. Maximum is here. Alright, 4 milliseconds. So I take my period 8 divided by, so I get 2 centimeters. Meaning one wave is 2 centimeters. Okay, meaning one wave is 2 centimeters. Only one wave is 2 centimeters. Okay, so it will be something like this lah. Maybe it will be something like this. Let me check. So 2 squares. And then one wave is 2 box. So it will be like this, no? Something like this. Go up and down. Yeah, something like that lah. Okay. Alright. 2 squares, 3 volts. Because now each cm is 1.5. Okay, so here 2 is 3 volts lah. And then 8 milliseconds. Total is 8 milliseconds. Alright, now I change. 1 centimeter is 4. So 8 divided 4, 2 centimeters. Meaning that one wave is 2 cm. So 1 cm, 2 cm. So correct. Alright, so that is how you identify the changes in your CRO. Okay, it's very simple. Okay, as long as you know how to calculate your peak voltage, how to calculate your period, okay, and then you will be able to draw the or sketch the different types of wave patterns. Alright, even in the objective they will ask you which one is the correct drawing, right? So based on this method you can calculate. Okay, alright, that will be it lah. Okay, more than enough for your first part, CRO. Okay, this part very important. Okay, next part will be about your semiconductors diodes. Alright, so I will see you again in your next video. Bye.